Good evening.
Good evening, sir.
Audible, screen visible.
Yes, sir.
Okay, so last Sunday we have discussed about the define phase of Six Sigma. Any doubts so far? Any clarification needed in define phase? Okay. So we have learned that what is Six Sigma? Six Sigma is a project management it's kind of project management. What kind of project management? Quality improvement projects, cost saving projects, problem solving projects, etc. So last time I have told about project and operations. So why do we need project? The two big challenges in front of any organization: maintain and transform. So maintain means is all about day-to-day activities, operations, and transform means transforming your business processes, systems, and maintenance is all about today, and it's about sustaining, not sustaining, surviving. Transforming is all about sustaining. Like if you want to sustain in another decade, so you need to keep on transforming your business processes, systems, everything. So today you cannot use the same technology tomorrow. So everything is done through projects. So project is a one-time unique, which has a start and end date, and operation is continuous. And Six Sigma is one kind of project which we use to solve the problems, quality improvement projects, cost saving projects, etc. Now Six Sigma projects are done. There are many project life cycle. If you ask about different life cycle, there are agile life cycle, project management, then traditional, or we call it as waterfall. Everything has a phases, different phases of doing a project. So similarly, Six Sigma phases of Six Sigma projects are DMAIC. Six Sigma projects are done in a DMAIC phase. So define is all about identifying a problem, selecting a problem, then properly defining it, and then once define is over, we go to the measure phase. Now the measure phase is all about measuring your current status. Where do we stand now? Now here we are going to learn today. Let's learn about measure phase. So I said to Himanshu that what I will do is one day we can have through Zoom meeting. So I will give a WhatsApp group. I'll create a WhatsApp group and I'll save to send it to Himanshu. You can all join in that WhatsApp group. So one day we will sit in Zoom so that I can split you in different rooms so that I can give a small task, like give you a small project scenario, and then you can make a define that project, or you can make a define phase in team wise. Suppose we have 100 people, so we can split into some 10 teams. So I'll give a task and you can do it in team wise, because Six Sigma projects are done in teams. So you will understand how it is done, and how teams used to sit for meeting and then analyze the data, etc. So one day we can do like that. I'll share the link to WhatsApp link to them, and I'll give a Zoom link so that we can do like that, so that you will understand how a project is undertaken. Okay. Now before that, let us understand the theoretical concept, like measure phase. What are the things we do in measure phase? Is it okay?
Yes, sir.
You want that?
Yes, sir.
Okay, right. Right, then let us proceed. Measure phase. So in the measure phase, what are the things we do? First thing in the measure phase is developing as process map. Now in the define phase, first thing was we identified a problem. So then we had a team, And then this problem is we made into problem statement. I hope you remember the problem statement. Then mission statement. And then there are 2-3 things like SIPOC, supplier input process output customer. Now SIPOC is actually a measure defined phase tool, but
Hello, sir.
the 3 parts of SIPOC, the IPO, that we are going to learn today. So that time I will talk about SIPOC. So when you do all these things, and
Hello,
then
sir.
you make a like a PPT or a 1-page or 2-page document, this all combinedly can be called as, you also will make a schedule. And
Excuse me, sir.
yes.
Sir, is there some disturbance from your side, sir?
Is it so? Is it with everyone or only one person? All are facing same issue with my mic?
Yes, sir.
Yes,
It
sir.
is
Yes,
fine. A bit of the voice distortion in between.
It's happening, sir.
So I'll do one thing. Let me switch off and see whether this mic after switching off and on is it works. So let me try it. Just give me a 1 minute. Am I audible now?
yes,
Yes,
sir.
sir.
Is it clear now?
Yes, sir.
Yes, sir.
Better? Okay. So define phase, we identified a problem. We made a theme and problem statement, mission statement, then schedule, then SIPOC, etc. And then once you make all these things and maybe a 1 or 2 page document or a 1 or 2 slides in a PPT, so we can call it as project charter. Now there is no limit in project charter. If you want to add business case, you can add business case also. Constraints, scope and constraints, if you want, you can add scope and constraints also. All these things can be done in project charter, but minimum this is required in a project charter. So once a project charter is approved by the top management, the project champion, then we are going to the measure phase. Now in the measure phase, what are the first thing that we do? It's about developing as-is process map. Now everything is done here. This is the journey, actually real journey of problem solving starts with understanding the detailed process map. So let us learn what is this process mapping. So, and these are the things we'll be learning in the measure phase. We are going to learn about process map. Then we learn about CTPs, CTQs. We'll know what is this CTQ and CTPs. And then planning for data collection, basic statistics. In the basic statistics, we learn descriptive variation, histogram, etc. Normal distribution, all just concepts, not much in yellow belt, just concepts, but we'll learn everything in detail in green or black. Then a process capability study. These are the major steps in measure phase. And then let's go one by one. So first, let us understand what is process and all the variation, gist of Six Sigma, everything we will understand in this. Now, who can define process? Can someone define process? What is a process? Yes, anyone can define? Anyone? Am I audible?
Yes, sir, you are audible.
So anyone can define what is process? Okay, so
So
I'll just, yeah, tell me.
the actions done for a particular purpose.
Yeah, yes, almost correct. So we can
A
define
way how
process
we
as,
go.
yeah, yes, we can say like that. Okay, we can, if you want to precisely define, we can say set of interrelated activities. So you are almost right, activities. It is set of interrelated activities that transforms input into output. This is the definition of process. Now, Six Sigma is process oriented. How many of you heard about ISO 9001? Have you heard of ISO 9001?
Yes, sir. On certificates, like they will give like
Yes,
certifications.
yes.
Yeah.
What is that
Quality
certification? Any idea?
certificates.
What certification?
Quality management, I guess.
Yes, correct. It's a quality management system standard. And this is a certification, QMS, Quality Management System Standard. You know, this ISO, initially ISO standard was developed in the year 1987. And that standard was known as 9001, 1987. Now, ISO has made more than 22,000 standards, maybe 25,000 standards so far. 9001 is just one standard. Now you have 14,001. You have ISO 17024. We are using this for as a personal certification bodies. Then 14,000 is for environment standard. OSAS ISO 45,001. All these things are standards, different standards which can be used these are all management system standards. Now, Quality Management System Standard, QMS standard, was developed in 1987, and this standard was known as 1987. Actually, there were three standards. It's 9001, 9002, 9003. Now, these standards, there were three different standards for quality management system. All these standards were there in 1987. Now, all standards ISO revised in around 7 years. So, in another 1994, they revised it again. So, same standard ISO 9001, 1994, 9002, 1994, and 9003, 1994. So, three standards, different standards in 97, 87, and then in 1997, again 94, again they have revised with the same concept. Now again in 2000, they made a revision. So then it was known as 9001, 2000. Now this revision was a major revision. And ISO 9001 became so popular because of this revision. Actually, before that, nobody knows about ISO 9001. But after 2000, ISO became so popular and everybody started getting ISO certification. And it was like ISO certification means you have followed your product will have a quality. Now, anybody have any idea now what is this revision all about? Any idea? Yes, may not be. Okay. So I'll tell you. Now, in 2000, what they have done, they have combined all these standards, 9001, 9002, 9003 into one single standard. Now, what was this standard all about? This is for manufacturing. 9001 was manufacturing standard. 9002 was some service related standard, and 9003 was some quality inspection related standard, something like that. Three different standards. Now in 2000, they have combined into one single standard and they named it same ISO 9001 QMS only, but they have introduced a concept called process approach. Process approach. Now the definition of process, what I said, process is a set of interrelated activities that transforms input and output. Is actually defined that time, and they called it the major concept of ISO 9001 2000 was process approach. Now, what is this process approach? process approach means they said that whether it is manufacturing or service, IT, pharma, whichever company it is, doesn't matter. Whether you are a manufacturing company, you are a service company, you are in banking, you are in IT, you are in pharma, it doesn't matter. Actually, the process is that transforming input into output. In service, there will be service related process. If you go to a bank, very old long back, around 20 years back, if you have gone to a bank, if you want to take out money, there is a process. You go to a one country, even today that's the same similar kind of process, but that time it was a different process. You go to one place, they will give you a token. Around 30 years back, the SBI logo of SBI was like this, isn't it? Something like this. Actually, this was a token given by the bank. People, when you go to one counter, they will issue a token, and then you will sit, and then in the other counter, you will give one document at one place, one window. You will give a form. From there, they will issue a token, and from this, you will go to another counter, and then from there, you will get the money. This was a process. So you are going to bank and you are following certain process, and then you are going to get your money. And if you want to open a bank account, you are going to a counter and then you are filling a form, then there are steps, and finally you get a bank account. So these steps are called process. So whether it is manufacturing, if you are in a manufacturing, a material will go into series of operations, and then you will get the output. So it may be manufacturing, it may be software, it may be in software, IT industries. There are certain processes, and you do that process, and then you make a website or a application, whatever it may be. So ISO says that whether it is manufacturing, whether it is IT, everything, it's process. So before that, there was a concept that you go and check your output. But ISO in 2000, they said that you focus on process and inputs, because input and process make the output. So then if you approach the problem solving in a process approach, then you can use this anywhere. Now it becomes a generic standard. That is why Six Sigma is, nowadays Six Sigma certification, green and black belt certification become a minimum requirement. A professional certification from a certification body is a minimum requirement for a job. You know why? Because the same reason. As every company need two jobs. One is maintain. Every company has this role, maintain and transform. Now here they get 100% of people. Everybody is expert in maintaining, but here there is lot of demand and not everybody is capable of doing this problem solving. So Six Sigma is one such skill where people are looking. They know once they have learned Six Sigma, they know how to solve the problem. So it is a generic approach which can be used in service, which can be used in IT, manufacturing, everywhere, every place Six Sigma is in high demand, a certification in Six Sigma. So Six Sigma is also about a process approach, understanding this, your output, there is a problem in output, then it is because of your input and processes. It is like this, like in very olden days, when there used to be a marriage alliance. शादी होना तो alliance में वो लड़का कैसे लड़की कैसे वो नहीं देखते थे, वो देखते थे खानदान कैसे है. So it's something like that. अगर इस खानदान से है, इस फैमिली से है, already उनमें वो value system होगा. So that's the concept. You focus on your process and output, and this is what Six Sigma also do. Your problem, if you have a problem in output, focus on this input and process. This is what Six Sigma is teaching you. Now, from this concept, everything is going to be, every complete Six Sigma further is depending upon this. So please be careful on this lecture, because everything is built on this. Now, can we call it as IPO, six input, process, output? So who is using the output? Who is using your output? Yes. Who is using the output? Tell me. Any idea? A rough guess? Am I audible?
Customers.
Yes, customers. Now, who is supplying the input?
Company, like service.
Supplies,
So we can call suppliers.
Yes.
suppliers.
Now, this is what is SIPOC. SIPOC. Supplier, input, process, output, customer. Now, if you make it in a chart, an Excel sheet, who are the suppliers, what are the inputs, what are the process, and who is the customer? Now, if you just make it in a process, in a Excel sheet, that becomes SIPOC. I said, no, there is a SIPOC in defined phase. You have selected a problem in defined phase. आपने एक प्रॉब्लम सेलेक्ट किया डिफाइंड फेस में, उस प्रॉब्लम को प्रॉब्लम स्टेटमेंट में बना के उसको आप सारे टीम यू अंडरस्टूड दैट दिस इज द प्रॉब्लम दैट वी आर गोइंग टू सॉल्व एंड दिस इज माय प्रोजेक्ट. नाउ ये प्रॉब्लम कहां हो रहा है, किस प्रोसेस में हो रहा है, इन विच प्रोसेस दिस प्रॉब्लम इज occurring. So that process we were going to study. In measure phase, we are going to study the process where this problem is. Okay. Now, so when you understand process, then every process will have some inputs and every process will have an output. So if you list down the process and input of the process and output of the process, if you list down, and then further, if you list down the customers, name of the customers and name of the suppliers, so it becomes a SIPOC. Now, what is the use of SIPOC? SIPOC, SIPOC, whatever people call it, whatever it may be. Some people say this copies. Somebody also called it as copies. If you start with customer and output process input, so it becomes copies. So some, I think Philips and all, they use its copies. So SIPOC copies, whatever it may be, it's same. So why do you want to make a SIPOC? Very simple. You want to know the scope of your problem, scope of your project. Where does it starts and where does it end? Who are the people who are going to involve? Who are all the suppliers that you may have to communicate with these people? Because you are going to do a project. You are going to solve a problem. So sometimes supplier may be involved. So you may need to communicate with them. So in the defined phase itself, we are identifying the scope. Who are all involved in this project? What are the inputs? What are the process steps? And what is output? And who are the customers? So this is what is SIPOC. Now let us understand the process in detail. Now, understood what is process. Processes are a set of interrelated activities which transforms output into input. So to understand a process in a better way, let's take an example of making a pizza. Now tell me, what are the inputs required to make a pizza? If you are making in your house, yes. Hello, is somebody speaking? I am not able to hear.
Sir, the maida required the base for the base.
Yes, flour we can say. Yes, flour. Yes. Then
And the vegetables and other cheese and other stuff.
pardon, what?
Vegetables and other stuff, sir. Cheese
Yes,
and all.
vegetables, yes, toppings. Yes, then
Cheese.
okay. All this we can say. Okay, this can be flour, oil, warm water, yeast, sugar, salt, topping, etc. So these are the input, and there may be some supplier to provide this, isn't it? Now, what is the process?
So putting it in the oven.
Baking.
But before that,
First
you need
making
to
the
make
base.
settings. No, straight away you will not put it into oven because you need to make a dough or not. Pour oil and all these things. So suppose, let's say this is a process steps. So this is process, understood? These are the activities. Somebody said actions, activities. It's actions or activities, whatever it may be. Now these are the activities. Somebody is doing this activity either through a machine or manually. If you are making in house, it is you are going to do it in this manually. So you will mix yeast, sugar, water, salt, flour, etc. Then you mix this, then you knead the dough, wrap the dough, rest the dough, divide and shape, find the build the toppings, bake the pizza, etc. Isn't it? What is the output?
So the final pizza is the output that can be
Yeah.
consumed.
And do you want it tasty? So a tasty pizza is the output, isn't it? Now, who could be your suppliers? Maybe your grocery shop in your society, isn't it? Vegetable vendor nearby. So you can have the suppliers. And who is the customer? If it is made by in your house, so the customers, your family members, etc. Isn't it? Or you want to make it for your girlfriend, whatever it may be, whoever may be, accordingly the customer. So you can identify who are the customer. If it is a shop, then you can identify the local students, like etc. So you can define the customers, who are all the customers. But this is the process, isn't it? Now what happens? Today you made it for, you learned it through YouTube, and you made it for your girlfriend or made it for yourself. And the next week you thought of calling your girlfriend and making a pizza for her. But today you made it very tasty. But next week when you actually made it for your girlfriend, but it was atrocious. You cannot, she cannot keep it in her mouth. It's so atrocious pizza you have made. It happens or not? I know you don't make it, you just call them to and go for an outing, that may be, but it happens or not when you're making yourself or in your house or whatever it may be. This variation happens or not?
Yes, sir.
Yes, sir.
Sometimes.
This variation happens or not? Now this is what we are going to learn. Okay? So every time pizza is made, the quality and taste varies. Now why this variation? So now this is going to be not only gist of Six Sigma, this is gist of quality, not only this is gist of quality, this may be any problem solving, research, even for PhD research, and even in your chemical industry also, this is going to be the same concept, scientific thinking, or gist of Six Sigma, whatever you call, it is, this is the gist of Six Sigma. The quality of output, why? We denote it as Y. Output is denoted as Y. Depends upon. Now, what are the words for Y? Depends upon. What depends upon? The quality of inputs and quality of process. If you understand this, you can solve all the problems in your processes. So now this quality of output. Now, how can you define this quality of output? Now let's consider this as you are going in a shop, restaurant, and you are ordering in a restaurant shop. What are the parameters that matters for you as a quality of as a customer? What are the
Surroundings.
parameters? Pardon?
Surroundings like cleanliness.
Okay, obviously imagine that it's a very good restaurant, ambience is okay. But considering the pizza, what are the quality parameters?
Taste.
Softness of the crust, taste.
Softness. Okay. Then
The
Amount
taste.
of toppings.
toppings. Okay. Then
It needs to be cooked rightly, not overcooked, not undercooked. Perfect cooking.
baked perfect. Baked right. Okay.
The size.
Size. Okay. Then do you want it cold or hot?
Hot.
Freshness.
Freshness.
Hot, isn't it? Now in this, what is measurable? Can you measure how softness is there? How can you measure softness?
So you can only measure one if you taste the pizza.
Isn't it? Softness measuring is not right. But what about toppings? Of course, you may measure it. You can measure like a number of toppings, isn't it? Number of toppings you can say. You can, what are the varieties of toppings? That can be measured, isn't it? Baking right after tasting. Size can be measured or not?
So we can like whatever the price that has been charged, we can judge from the.
Yeah, isn't it? Sizes
That
can
is
be measured.
measurable.
And hot can be measured or not?
Hotness.
It can be felt, but it cannot be measured.
No, measured means not, I am not talking about you. I am talking about the restaurant owner or the quality system of the restaurant. Can they measure or not?
Yes, sir.
Yes, sir. In oven they will keep, no?
If they are heating it
I
at
know
a
you can
predefined
keep, and they
temperature.
can say now, can you just say, for example, let's take that you need it like 120 Fahrenheit plus minus 5 Fahrenheit. So now the restaurant quality management says that I should serve it at 120 Fahrenheit plus minus 5 Fahrenheit. Now this is what the quality of output means. Now this quality parameters, we call it a name called CTQ. That means critical to quality. An output specification is known as CTQ. Critical to quality means with respect to the customer perspective. Now we can also take that, for example, delivery time also can be done, order time. Suppose you want to order, you go and they say that within 15 minutes. So delivery also is a CTQ, that 15 minutes plus minus 2 minutes. So now out of this requirement, let us consider these two are the most critical to quality, critical to customer. Now this is known as CTQ. Now you have learned two words for the output. One is we call Y. If someone write in the Six Sigma parlance, if you write Y, what does it mean? Output. And CTQ means same. So what are the things that you mention for output? Y, you can write Y and you can write CTQ. And then there is one more word. See, it is depends upon. So what is the other word for Y?
Dependent.
What is the other word for
Dependency.
Y? Yes, dependent variable. Have you heard about or not?
Yes, sir.
Dependent variable. Isn't it? Dependent variable. So Y, CTQ, dependent variable, everything we denote for output. This is why we call Y as dependent variable, because the variation in Y depends upon. Have you ever wondered why we call Y as dependent variable? Because every variation in that output depends upon the quality parameter. That's why X we call, what is X? X we call as
Independent variable.
Independent variable.
and independent variable. Isn't it? So when you call independent variable, that's why we call X as independent variable and Y as dependent variable, because the quality, the variation in Y depends upon X. So these are X's, inputs. Even the quality parameter also we call it as, quality of process also we call it as input. Now there is another call name similar to CTPQ. We have another name called CTP. Now what is CTP? Very simple. Suppose if you want to mention why this variation, because you have not defined the parameter. Suppose if you are making the flour, how much? Half kg. Define it. For half kg, how many people you can have? How many tablespoons of water? How many tablespoons of dry yeast? So all these things, when you specify, suppose for example baked pizza, so 500 Fahrenheit, for 10 minutes. So it is a defined thing. Rest down. So how much? 30 minutes. 30 minutes with a polythene covered. So all these things are called what? CTPs. Critical to processes. This is also now ball. If you want to define this, you can say small size, medium size, or big size. Use a medium size ball. So define everything. Then it becomes CTPs. And critical, most important, study on them, because this is the reason of variation. So these are CTPs and CTQs. Now the complete gist of Six Sigma is this. Variation in output is because of variation in input. Okay. So here we call, you understand the gist of Six Sigma, the quality of output. So what are the words you use for quality? CTQ, dependent variable,
Output.
and Y or output, all are same. Here input, independent variable, then CTPs, all are same, isn't it? These are all called CTPs and CTQs. Now the gist of Six Sigma is known as Y is equal to f of x. That means Y is a function of x. Now the complete Six Sigma problem solving is based on this. Y is equal to f of x. Y is function of x. Now in the measure phase, we are going to learn about the different data types. Okay. And X and Y, etc. Then all these things. This is learning Six Sigma is, this is all about learning Six Sigma. Okay. Right.
Sir,
Now,
what is the
where
full
do you
form of
find
CTP?
this? Pardon?
CTP full form.
Critical to process.
Okay, sir.
Sir, I had a doubt in this. Actually, all the parameters which we are considering in input, so are all those inputs critical to process?
No. Good question. All are not CTPs. There may be critical. Now I am coming to that point. We'll come to that point. Not all are critical. You need to understand what are those critical parameters that affects your output. Okay. That is what the problem, in the problem solving, in the measure phase, this is what you are going to do. Critical parameters, not all are critical. Okay. So CTP, CTQs means it should have a description, a metric, a target, and tolerance. For example, description, we say hot pizza. And metric, you say 120, a metric is Fahrenheit. What is the measuring? What is a metric? Means unit of measure. Nothing but unit of measure. And target of tolerance. What is the target? 120 degree Fahrenheit plus minus 5 degree Fahrenheit. So when you make all these things, then only it becomes CTQ or CTP. Both CTQ, CTP, both should have like this. So for example, baking temperature is a CTP, baking temperature. Again, that is measured in degree Fahrenheit or a degree Celsius. 500 degrees centigrade plus minus 5 degrees centigrade, maybe a target and tolerance. Now, baking time is also a CTP, baking time, and it is measured in minutes. And what is the target? 20 minute plus minus 2 minute. So you need to understand, especially in your chemical processing, this is very, very important. A small variation in output, many of the time you must have noticed it during your chemistry lab. You must be doing combining 2-3 acids, base, whatever it may be, and then you get an output. So there is a process and then you get an output, but in the output you are not getting the correct specification. Why? Because either you made a mistake in input quality, input quantity. Suppose you must have taken one thing, the quantity of that thing became slightly different. And that makes you experienced it in your chemistry lab, isn't it? So same thing we are learning in Six Sigma. We are trying to do, then everything is based on these CTPs and CTQs. Okay, we'll learn it one by one. Right, understood. Okay, now to understand the process in detail, is any doubt?
Previous slide 1 minute, sir. Can you show?
Pardon, your voice is not clear.
Sir, previous slide 1 minute, sir. Previous slide.
Okay. Okay.
Okay, sir.
Right. Okay, then types of flow diagram. Okay, now we'll learn about a flow diagram. Now we are going to learn about flow diagrams. Flow diagram means it is one of the important tool in Six Sigma to understand the processes. There are two types of flow diagrams. One is high level, and during the SIPOC, when you make a SIPOC in this one, what do you say, define phase, that time you are not going to make a detailed process, just an high level process, and then you have detailed process. So suppose this is how an high level looks like. So a e-commerce store, customer places the order received and entered, order filled and shipped, and the customer receives the good. Now these are high level, but each such process will have a detailed steps, order received and entered. In the order received and entered, there will be a lot of small steps that is to be followed. So the SIPOC, when you learn SIPOC, when you make in SIPOC and you define phase, SIPOC. So here this process is just high level. No need to write a detailed process in SIPOC in define phase. The detailed process we are going to study in the measure phase. Detailed process. You need to learn the detailed process in the measure phase. Then, so these are certain simples used for flow diagram. Simples. Like a rounded rectangle is used for start and end. Then this is used for activity. Then this is used for decision, delay, connecting lines, etc. These are the minimum required in a flow diagram symbols. For example, suppose let's draw a process flow diagram for making a tea. Now, what is the first thing? So, let's see if you want to make a flow diagram of the process of making a tea. So we make it, first thing is start. So every process will have a start and end. Now this start and end is represented by a rounded rectangle, and activities are used in a rectangle. So first is start, then you boil water. Second activity, add leaves, add milk, add sugar. Once everything is made, then what you will do? You will check. Now this is a decision symbol. And once you check, and if you found that taste is not okay, then you will see what is wrong. Then whether leaves are less, or it is because of milk, or it is because of sugar. So you rectify it, and then you drink the tea and that. Now in the process mapping, this symbol as this is an important symbol. Why? Because this is a place where you find the reworks. Here you will have data. You can get a lot of data here. You will have a register here that people can write data that this much rework happened last time, etc. And there is another thing. Important thing is, this is the place the arrow is going back. Otherwise, arrow is going to one direction. All of a sudden, arrow is going to the opposite direction. Arrow going opposite direction is all about rework. rework, rejection, etc. Now, the process steps. Now, this process is a tea making process used by tea tasters. This is the actual way of making process. There are different processes. If you come to north side, you will have doodh patti. Milk is boiled. In the boiled milk, you put the leaves and it's boiled again and again. And then they put the sugar and then maybe some ilaichi and then you give the tea. That's called doodh patti. But in south side, what is happening? You'll boil the water first. And boil the water. Once the water is boiled fully, then they put two spoons of leaves and then they just close the close the stove, and it is keep a lid and then wait for another 1 or 2 minutes, and then milk is added and then sugar, etc. This is how it's made in south. So there is taste difference. The process you follow a different process, your taste varies. So the process steps makes the quality. So what type of quality you want? This is the best example is you are cooking, when you are cooking. So there are a lot of cooking videos in YouTube. Now, if you want to have a cooking, you don't have to worry. You may start first day, even if you are not cooked in your lifetime. If you want a good dish, if you are going in a hostel or you're staying alone, if you want to make, you can make it very easily. Why? There is a video process in YouTube. That's why YouTube is formed. You can learn everything in YouTube. Actually, what is that you are learning? You are learning the process. So you're learning the process, and if you're following the process same way, even if you're doing for the first time, you can make the tasty food by just seeing that video. So that's a process. Now this is process flow map. Nowadays, I used to be judged for quality circle projects by Mahindra and Mahindra, Tata Motors, Maruti, etc. for CII, Confederation of Indian Industries. CII always regularly conduct. There's what do you say? Sorry for the background noise. They regularly conduct this competition. Now next week there's national competition. I am judged for that also. So around 1,000. So far I have evaluated more than 7,000 projects. So then when this projects come, I always give them suggestion to make videos for processes. This was used earlier. This is used. Such kind of documents are used. We call it as a one picture is equal to 1,000 words. Now I used to say people now one video is almost 100,000 words. So make video SOPs. Make the videos of your process. It can be used for training purpose. It can be used for solving your problems. It can be used for checking whether this process is followed or not properly. So your problem in output is because of you are not following the process properly. So learn to follow the process properly. So this is an example of flow diagram. And for example, let's say that a process of a logistic operation officer. So see, now you know whenever you are going to any organization, if you're going to an organization, if you want to become the expert in 1 or 2 days, just try to understand the process. Every company will have this process flow charts. Every company will have this process flow charts. It means you are going for an MNC only, MNCs will have this. So if you want to learn it, if you want to learn the process in 1 or 2 days, you can very easily learn. Just understand, see their process. Where is this process map? Is there? Their process map. And see what are the activities and go and see how it is done one by one. So for example, a logistic officer operations process flow chart. What are the steps that you have to do? You have to check the roster for incoming deliveries. Then you will see whether delivery is imminent. Then update manifests from supplier file. Then it goes to the loading bay and then check the driver's detail, etc. So just by looking at this, you understand what is a process of a logistic officer's process. And then any problem is there, it will be escalated to logistic manager. Now, if you go in detail, then logistic manager will have another process. So it becomes process approach. The output of one process is input of another process. Now, this is called process approach in ISO. So understanding and learning the process is important in Six Sigma problem solving, because until unless you don't know the process in detail, you cannot solve the problem in that process. So in the measure phase, once you identify the problem in your define phase, you identified a problem, and then in that problem you have made a problem statement, mission statement, etc., and then you went to measure phase. So in the measure phase, you are going to learn the complete detailed process flow. Understood? Okay, then CTPs and CTQs we have defined earlier also, CTPs and CTQs. Okay, this is what is, somebody asked me this question. So this is clear to you. Now output, we call output as Y dependent variable. All these things are same. Output is CTQ. When you define the specification of output, it becomes CTPs, CTQs. Now you have a lot of inputs. Now what are the different kinds of input? All these inputs are known as 5 M's. Man, material, machine, method, and mother environment. So all these things are kind of input. Now you need to understand what is that critical input process parameter. So not all are CTPs. Now you have, suppose you have XN, X1 to XN. Suppose this you have 20 inputs and process parameter together, you have 20 parameters to check. Now not all are CTPs. You have to identify what are CTP, what are critical to this process. Now if you are going to, now suppose out of this 20, maybe 4 may be very critical, which is affecting. Now this, your process knowledge will tell. You are a chemical engineer, now you are going into some particular process, and you know these parameters in this chemical engineering I have studied, these parameters are important. So the process knowledge, process engineers decide this. What are CTPs, what are CTQs? Is it clear? Who asked this question? Doubt? Now is it clear to you?
Yes, sir.
Yes. Now next is measurement system analysis, but we will do it later. MSA I will tell you later. Now 5 M's you learned. What are 5 M's? Can you tell me what are 5 M's?
Man, material, machine, method, and mother environment.
Now 5 M's are kind of input. All inputs are either in this way. Process input, not money input I am talking. The process input. Input to the processes are these 5 types of process. Now there is also called 6M, something called 6M. Same 5M plus one more M. Can you tell me what is that M? We will add one more M into this and it becomes 6 M's. Any idea? Just look at the slide. Measurement. Now, these are the 6M are also the sources of variation. We call it as sources of variation. Any variation is because of these 6 sources. The variation will be because of man. Now what happened? You, after passing out your graduation, you may join in some MNCs. Now you have been given in charge for a process. Now you are totally new. And some errors may happen from your side. Some mistake may happen from your side. Because you are not that much experienced like a person. So in your first 1 or 2 months, you are prone to make more mistakes. But when you are, you have experience of 1 year, 2 year, 3 year, 5 year, so you are going to make less errors. So man is also a source of variation or not? Man is a source of variation?
Yes, sir.
Yes, isn't it? The skill, knowledge, age, efficiency, everything. It matters from one man to another man. Man means human resource I am talking. Anyone, it's not only man, woman, whoever it may be. And material. One material is provided by, for example, making a tea. You can have tea leaves, some Tata tea, Lipton, Rockbond, whatever company you may be, or from a local vendor or directly from the garden. So material, you use different material, you get different taste or not? Yes or not? So the input, these are all sources of variation. Machine. In SBI, I went to bank yesterday and they were facing problem. Now one counter and another counter. One counter, it is very slow. Variation. Actually, if I am going to a counter, your process should be finished in at least minimum 1 or 2 minutes or maximum 5 minutes. But you are taking 15 minutes. Variation. Now why? Because that computer is very slow. The staff was fed up with that computer. They were discussing each other. So this is very slow. And somebody said, please restart it. She said, before restarting, it will take another 30 minutes. So the machine may be a source of variation. Method, I said, example, Doodh Patti and making example. So if you are showing the method is different, the taste variation will be different. Taste will be different. Mother environment. It's all about humidity, temperature. You are working in a hot summer in a factory without cooler, without proper air, and such a humid and hot condition. Naturally, the workers or people working in that slow down their efficiency. They may skip 1 or 2 quality parameters. They were because of fatigue and all. So that is also a source of variation. Now, what is the last source of variation?
Measurement.
Measurement. Now, we separate this source of variation and we want to ensure that before we are doing to that collecting data, we want to ensure that you are able to measure MSA, your measurement system is good to get a reliable data. Because if you are not able to take the measurement and get a data, proper data, then a complete Six Sigma effort is waste. So 5Ms, all other 5Ms will be analyzed with the help of data. So you need to ensure that this data is variation free. So that is what called measurement system analysis. So before collecting the data, if a measuring device is involved, you must do an MSA first before collecting the data. Why? Because there should not be any source variation because of measurement. It can happen or not. It happens. There was a company in Ludhiana. They were supplying piston rings to GM, General Motors in US. They were exporting it. And they were facing a lot of rejections, in-house rejections. They made a project and then they could not reduce the rejection. A lot of problem happening. And one day they realized that there is no problem at all. The product is good, but people do not know how to take measurements. When you have, especially you have a traditional manual gauges, vernier caliper, micrometer, if you are not training the people to how to take measurements properly, they will not be able to take it. So MSA is a big tool. We will learn it later. But understand that this is what is MSA. You just wanted to ensure that the variation because of measurement is not there. Understood? Clear? Any doubts so far? Anything you want clarification, more clarification, or more explanation? Let me know. समझ में आ रहा है कि नहीं? Or you are wasting a good, beautiful Sunday? सच सच
No,
बताओ.
sir, it's good.
सच सच बताओ. सच में?
Yes, sir.
Okay, right. So I can believe you. Okay. Please let me know anywhere you want more clarification. Are you getting a picture? Now you need more rooms. We are going to do a lot of things now. So फिर भी थोड़ा clear हो रहा है कि नहीं आ रहा है picture?
Yes, sir.
Sure. Right. Okay. So MSA we will not discuss now. MSA we will discuss later. So these are the process of MSA. We will not discuss it. Yes. Now let's come to data. Planning for data collection. So in the define phase, you have identified a problem. Maybe rejection problem, maybe rework problem, maybe productivity problem, maybe specification not meeting problem. A lot of things can be there. There are a lot of problems. It's all about identifying the right problem and selecting it as a project. So define phase mein ho gaya, then we go to measure phase. So in the measure phase, we understand पहले तो पूरा process को flow करते हैं. So Hindi is comfortable to all, I think. Anybody not comfortable with Hindi? In between, I can use Hindi or not? Anyone from
Okay,
South?
Sir. Yes, sir. It's
Okay.
fine.
Yeah.
Yes, sir.
Actually, मेरी हिंदी भी इतना ये नहीं है. मेरी हिंदी भी गरीब है. I'm a South Indian Malayali. So, but still, I feel okay if I can mix Hindi. Okay, no, is it okay? Anybody have face problem? Please let me know.
no, sir. We are from Tamil Nadu, sir.
But
Yes,
so I
sir.
should not use Hindi.
Sir, can I just please continue with English, please? It will be better.
Okay. So in between one or two words I can use, no problem. Right. Right. Okay. So in the measure phase, in the define phase, we identify what is the problem and then make a proper problem statement, etc., project charter, and then we went to measure phase. Now in the measure phase, first thing we did was understanding the detailed process flow. Where is that problem? And then understand the detailed process flow. And then we identify CTPs, CTQs.
Excuse me, sir.
Yes.
Sir, sorry to ask you this, but will this lecture be shared? Because I'm right now in an area where internet connectivity is really poor. So just.
I can, you ask this Himanshu or who is the coordinator, other coordinator, Rishikesh? So this is recorded and it is shared in even my previous lectures also there in the IICHE YouTube channel. Okay. I think this is shared to you.
Okay, sir. Thanks a lot.
Right. So measure phase, in the measure phase, we understood the detailed process flow chart. Okay. Detailed process flow. And after detailed process flow, we listed down CTQs, CTPs. CTPs and CTQs are nothing but the important parameters of output and important parameters of the processes and inputs. Then what is next? Next is data collection. So we need to plan in data collection. Now let's understand what is data collection, data types of data, etc. Let's understand. So let's see now what is data. Data is record of actual observations. And it's example of many example. For a cricketer, it may be runs, average wickets, etc. For a quality person, it may be rejection, rework date, anything. For a salesperson, it is sales figure, output, stocks, etc. So data and facts are the backbone of every Six Sigma projects. And without facts, problem-solving efforts are reduced to guessing game. Chances of success are low. Now, this is a big reason for failure of Six Sigma projects because of improper data collection, improper analysis, etc. So data and sources are, data and facts are the backbone of Six Sigma project. So now let us understand the different types of projects. Now suppose let's take an example. You are in one of the manufacturing company, in an auto parts manufacturing company, and there is a this called a product called crankshaft rotor. It may be. Now you want to ensure the quality of that. So during the quality inspection, during the run, suppose you have taken 10 output and you just measured it. So you got an output like this, measurement of this 10 shafts like 19.1, 18.5, 17.9, 18.2, 19.5, etc. This is one scenario. Let's see another scenario. Now you are a manager in a 3-star hotel and you are interested in number of guests checked in per day, and your outcome for the 5 days, it comes like this, like something like that, 100, 110, 90, 105, 95, etc. Now tell me, what is the similarity between these two data types and what is the difference between these two data types? What is the similarity? Yes, anyone? What is the difference? And
So
yes.
they both are so these data sets both are defined. I mean, if you take the diameters, it's for like 10 samples, and if we take the manager for 3-star hotel, it is the collection of 5 days. So they both have a sample
Can you
space.
call it as quantitative both? Both are in numbers or not?
Yes, sir.
So it's a quantitative data. Both are quantitative, isn't it? Both are numbers. That's a similarity. Now what's the difference?
Number of observations.
Yeah, this is in fractional value and this is a discrete, isn't it? The difference is now this we call it as continuous data. Continuous. Now that means continuous means, for example, 19.1. Let's say 19 to 20. How many data can take place between 19 and 20 fractional values?
So infinite.
Yeah, infinite, isn't it? Continuous. You cannot count. It is continuous. There is, between 19 and 20, you have infinite fractional values. But here, 100, 101. Suppose we have today in this session, let's suppose we have 100 students. If anyone joined, how many students? 101. If anyone left, how many students? 99. It cannot have, so this is called discrete. Count data. Now this is a measure of, this is a result of measurement. Continuous data is a result of measurement. You need a measuring device. So you have something, it's called a continuous data. The other one is called the discrete data. So if you want to show this data, you can say something like that. 100 people, next webinar 50 people, another webinar. So a bar graph, with a bar graph, you can graphically represent this. But here, can you represent the bar graph?
No, it will be scattered chart.
Isn't it? But still you can try to have a bar graph. Suppose.
So you can put this in a histogram though.
Yeah, histogram. Suppose I say 17 to 90. How many numbers are there? The frequency.
So 2 numbers.
Isn't it? So something like this you can make. Maybe like this. I know. So what do you call this graph?
Histogram.
Histogram. Now tell me, what is the difference between histogram and a bar graph?
So bar graph represents absolute values or the discrete values. Histogram can be used for representing sets.
Very good. So this is used for continuous data, isn't it? Continuous data. And most importantly, there is not going to be gap between bar graphs, histogram. Histogram, here in the bar graph, there are gaps. But in histogram, there is a meaning of the width of the bar. Suppose if I say this width means 17 to 19, the measurement between 17 and 19 mm. This bar represents this width represents this width represents 19 to 21 mm. So the width, there is a width in the bar graph. The histogram, there is the meaning of width. But in bar graph, there is no meaning of width. Bar is just one bar, consider one value, one discrete value, 100 people, for example. And if you have bar graphs, will always be like this, whatever it may be. But when you have so many millions and millions of data, and if you want to represent a continuous data is represented something like this. This is called the normal graph. Sometimes it may be like this also, right skewed, and like this also, whatever it may be. All these things are different distribution, probability distribution. This is known as a normal probability distribution. Normal probability distribution. This may be a chi-square distribution or an F distribution, chi-square or F. It may be something like that, not exponential. This distribution is something different. This can also be an F distribution. So whenever you see such kind of graph, that's all called continuous distributions. Bar graph, discrete distributions always looks like this. So these are the two types of distributions, two types of data sets. One is continuous. Another one is discrete. So normally there is another word used in quality. Continuous, we call it as variable. Here we can call it as attribute. We will learn about attribute more. Now let's consider another two examples. Suppose now you are in a customer relations manager in a telecom company and you need to measure the satisfaction level of customers. So you conducted a survey, you got a result like poor, average, good, excellent, etc. And another example is you are in a, every 10 years government conducts census, and last census is just carried out last year, I think. And the census, the government official came, and then they have taken your marital status. So the result of that will be like this, something like single, married, divorced, widow, etc. Now tell me, what is the similarity between this data and what is the difference between these two types of data?
Similarities, it is qualitative, like
yes.
Before two were quantitative.
Yes.
So another similarity is that both of these data will be discrete. The nature of these will be discrete, not continuous.
Good. You can count it, isn't it? You can count it. Yes, correct. That's a similarity. Yes, you can count this, how many poor, how many single, etc. You can make in a bar graph. Yes, correct. Now, what is the difference? Any difference can you see? Okay. Now, the difference is this has a meaningful order. Is it not? There is a meaningful order or not? Poor is lower than average. Good is better than average. Isn't it? So there is a meaningful order. So these kind of data, we call it as ordinal data. Now here, is there any meaningful order? If you ask single people, they will say married is better. If you ask married people, they will say single is better. But is there any meaningful order? Like you can say single is better, married is better, drivers. Is there any meaningful order? There is no meaningful
Not really, sir.
order, isn't it? So this data is called as nominal data. Now, for example, here let's say 10th plus 2 BTech MBA. So we can very clearly say this data type is education qualification, data type is a ordinal data, isn't it? Is there a meaningful order or not? There is a meaningful order. But suppose here BA, BCom, BBA, BTech. Is there any meaningful order?
No.
No, all are graduation. You can never say BA is BTech, BA is lower than BTech. No, they are both are graduates. They are one BCom and BTech. All are graduate. You complete BCom, you complete BTech, you are graduate. You cannot say BTech is better, BCom is lower. Never, isn't it? So wherever there is a meaningful order, that data is known as nominal data. And this, wherever there is no meaningful order, it's called nominal data. So we can also call attribute data. Now, as someone said, you can convert this into discrete. There are two ways in writing in Excel sheet. Suppose you take data and in Excel sheet, you go to one house and you got a data type single, then you put next one was married, another one again single, then married, then widower, etc. If you put it in an Excel sheet, here the rows become like this, isn't it? Now, this is called row data in Excel sheet. Why I'm telling? Because in Minitab, I'm not going to teach you Minitab in this yellow belt, but in green and black, we'll be teaching Minitab, etc. In Minitab, we call it as row data in the column. Now, these data can be consolidated in a column like Excel also you can consolidate. Now, we can say single 60. You surveyed 100 people. Single was 60. Married was some 20, maybe 30. And the widower was some 6. Widow was some 4. Now you can consolidate into, and you can also express in a bar graph. So a row data as it is in an Excel sheet, and same Excel sheet may be a consolidated data, and then again in a bar graph you can make it like this, something like that. So these are the ways of representing the data. This is single, this is married, this is widower, and this is widow, whatever. So you can express it like this. No, you can graphically show them like this. So This nominal and discrete can be categorized same. Both are counts. One can be classified into counts. So basically, there are two types of data. Basically, two types of data. So variable and attribute in Six Sigma parlance, it is also known as variable data and attribute data. In the variable, you have continuous and discrete. Now, this also can be converted into discrete. So basically, we can say data as a result of what? Data as a result of measurement. They are continuous data. And data as a measurement, result of measurement, we can call continuous, variable, whatever you call. And data as a result of count. They are called attribute. So just understand this way only. Okay, very simple. Variable or continuous, both are data as a result of measurement. And count data, data as a result of count can be taken as an attribute data or discrete data, likewise. That's the best way to understand. Okay.
Sir, can you just
Yes.
move on to the previous slide?
Just a minute. Yes.
Okay, sir.
Any doubt?
No doubt, sir. Okay, sir.
It's okay? Right. So let's understand something. Your complete Six Sigma analysis is depending on this. Now, suppose your output Y or CTQ. Is it possible CTQ can be a continuous data? Is it possible or not?
Yes.
It is also possible in some cases CTP is a discrete data. Possible or not? You cannot measure everything, isn't it? Sometimes you may have to count also. Everything cannot be measured. That's why I asked, when you define the CTQ, there was softness. So how will you measure the softness? Maybe someone visually check and say this is soft and this is not soft. So at the end, when you check 100 pizzas, you can say 3 pizzas were not soft and 97 pizzas were soft. Now what is this data? 3 and 97. What type of data?
So it's a discrete data.
Yes, it's a result as a count. It's a result of a count. Now, if you want to do a problem solving here, the Y, what is this Y? Discrete data. Now you have a problem of softness of a pizza. Now you want to solve that problem. So your output is Y is a discrete data. Now suppose in the same case, your customer complains that pizza served is not hot. So in that case, what is your Y? Which type of data?
So it's a continuous data then.
Continuous, because temperature can be measured using a device. This data you are going to collect as a result of measurement. You need a temperature, this thermometer to check it. Some device to check the temperature. You need a device and sensor to check it. You cannot. Here you don't need any device. No measurement device is used. A person visually checks and he is expert in that to find, okay, visually you just check with the finger, press it and say, okay, this is soft, this is not soft. There is no device. It just count. So here temperature, there is a device. So it's going to be a continuous data. Happens or not? Similarly, X can also be continuous or discrete.
Yes, sir.
Isn't
Yes,
it?
sir.
Yes, sir.
So your complete analysis selection of tools depends upon which type of data is your Y and X. Now, capability studies for continuous, you have CP, CPK, etc. as a capability study. For discrete, you have DPMO, PPM, etc. for discrete data. Okay, love you learn it later. But is it clear to you now? Data type is clear to you? Somewhat clear, not fully clear, somewhat clear.
Sir, can you explain again the example?
Which I have shared you now.
The recent one, three hot pizzas and the softness of a pizza example.
Okay. Now, let's take that. See, we have taken critical to quantity as two things. One is temperature of the pizza and time served. Now, suppose you also have a CTQ called softness. Now, if you want to measure, now suppose you want to maintain quality in your company, when people want to maintain quality, they have to collect data also. Output data, input data, they keep on collecting. Now, suppose if I collect data for these two, for collecting now, suppose they, let's say 100 pizza is served in a day. So if they want to check the temperature of the pizza served, suppose they want quality people want to check. Now, what do you need? You need a thermometer type of device or not? A measuring device or not?
Yes, sir.
A measuring device is needed. And then if you select 100 pizza, now suppose one pizzas you have tested, and now that is around 138 degree Fahrenheit. Another one you have selected and that is 127 degree Fahrenheit, 132, 135. Likewise, you will get an Excel sheet or not. If you check 100 pizzas temperature.
Yes, sir.
Now, what is this type of data?
Continuous.
Continuous, isn't it? This is a continuous data. Now, one more CTQ is added. Softness. Somebody said the softness now. Now tell me, is softness can be measured? This is the question I asked that time also. Can you measure it?
No, no, sir.
Suppose, no, this is an issue because customer is repeatedly complaining that your pizza is very hard. Now your management, the restaurant management want to improve the quality, is a quality conscious person. He used to take customer feedback. Now he wants to improve. Now what is that he need to do? He has to keep a parameter to check softness also. Now how can you check it? Now there is no way, no device is there, no measuring device is there. Only you can do that with your experience, the cook's experience or experienced people, they will ask here, you touch it. After making it, you just use touch and see whether it is soft or not. So with your experience, so you can just touch and say whether yes, this what do you say, this bread is soft, this pizza base is soft or not. So somebody has to do it like that. There is no measuring device.
Yes, sir.
Now suppose you have checked 100 pizza. Now out of this, 3 pizzas you got it hard and 97 you got it soft. Now these 3 are rejected or not because of hard?
Yes, sir, rejected.
Now tell me this 3 and 97, what type of data is it?
Discrete.
It is this data, this is a result of a count. But here it's a result of measurement. So this is 3, and there cannot be 3.5 pizza soft. No, either it is 3 or 4. But here it can be 138, it can be 135.5, it can be 135.2, it can be 134.8. Any value can take continuous data. So here this CTP is a continuous, this CTP is a continuous, but what about this CTP?
Yes, sir.
So when you solve a problem, you are actually looking at what is a Y, what is X, what type of data is X, what type of data is Y, because afterwards your complete selection of tools depends upon these type of data of X and Y. Got it or not now?
Yes, sir, got it.
Understood? Right. It's 5 minutes to 6 o'clock. Shall we take a 15 minutes break? Okay.
Yes, sir.
Now we'll come back at 6:10 p.m. Okay. Right. See you at 6:10. Are you back?
Yes, sir.
Shall we start now? Okay, now next is some basic statistics we'll learn. I know Six Sigma is Six Sigma also involves statistical tools. So let us understand the basic statistics. You may be knowing, but still will let us understand in a different perspective. Now, what is statistics? Statistics is a way of getting information from data. Now, what is information? What is data? Data is record of actual observation. And for example, marks of 35 students in a science class, etc. And then data are useful only when we generate information from it. Okay. Now, what is information? Information is simple way. It's answers to question. Suppose the class teacher wants to know how many students score below 50 from this data. So data is useful only when we generate meaningful information from it. So we have 35 students data in a science class, and the teacher wants to know how many people score below 50%. And then she may also have how many students score above 50 per 90%. What is the trend of the pass percentage for last 3 years? And what percentage of students are expected to pass in the upcoming exam based on 3 years trend? Now, what is the difference between the last question and the last information and the first three information? First three information and the last information. What is the difference?
So the first three information are discrete. Last three information may be continuous.
First three describe the count of students, and the last one.
The last is actually the percentage. It's the range actually, like how many are
how much students are expected to
but
pass.
that is not the question I asked. Actually, of course, you must have. That is also correct. How many students it is discrete? Yes, but this is not discrete, no? This is not discrete. It's actually, this question is not about discrete and data type. This is not about data type. This is information. The question is about the information. Okay, no problem. Actually, you must have, since I was discussing about the data types, you must have confused with the question. Now tell me, if I want to give an answer, can I give an 100% right answer here?
No, sir. No, sir, you cannot.
Suppose you have 35 students, mark of 35 students. I am going to generate the data from this 35 students. No? So whatever 100% right, I can give it, isn't it? Suppose you have 100 people. 30 marks of 35 students, isn't it? Now, this mark is below 50%. Now, out of 35, from the data, I found that 20 students score below 50. So I get the right answer or not? 100% right from the data?
Yes, sir, but in that case, aren't you manipulating the data there?
Data I already have.
Sir, but in that case, aren't you manipulating the data by yourself? I mean, you are not giving the complete data on which
No,
these
I am talking
percentages
about only from this 35 students only. I am asking
Okay.
from this 35 student, I asked from this 35 students data, how many students score below 50%? So from this data, I will get a 100% correct data.
Yes, it is showing an actual result only now.
This is actual data only, 35 students data, and I want to know from out of 35 students, how many students score below 50% mark?
Okay, then
From this
then you
data.
will be 100% correct.
100% right data, isn't it? I'm not talking anything from outside. I am talking whatever data I have. And from this data, I can generate this 100% correct answer or not. Because 35 students, I know in this 35 students, 20 students scores below 50%.
So that's a correct information or not? 100% correct information.
Yes, sir.
Yes,
Right
sir.
or not?
Yes, sir.
Similarly, how many students could, maybe my question is not clear to you, but now it's clear. Now, similarly, can I get an 100% result data here, the correct data here?
Yes, sir.
You know, isn't it? I know that suppose 5 students scored above 90%. I can say out of 25, 5 students. So that's correct from the data, 100% right, I say. And what is the trend of pass percentage for the last 3 years? I have 3 years data. In that case, can I get a 100% result here?
Yes, sir. Actually, the trend will be based upon our data sets only now.
Yes. But what is this? Can I give a 100% right answer here?
No.
No, sir, you cannot.
This is
Here I
basically a
cannot.
prediction.
Isn't it? Because here I have to, the information sort is what percent of students are expected to pass in upcoming exam based on the 3 years trend. Now I cannot give an 100% right answer. I can only say the pass percentage is 60% people, students will pass, and then I have to say with my probability, with my confidence. So I can say, suppose, let's take it like this way. I can say around how many students are expected to pass from 35. I can say 30 students are expected to pass, 30 students. Then I cannot say it 100%. So I may say 95% chance. So here I don't have to mention the accuracy because it is accurate, 100% right. But here when I give, I need to mention a chance, probability. You got it or not? Now these are
Yes, sir.
branches of statistics. Now these two branches have statistics. Now these branches, this is the part of descriptive statistics. Descriptive statistics. Now this is part of inferential statistics. Inferential statistics. So inferential statistics is all about probability, chance, etc. So a certain kind of predictions are there. So what is statistics? Statistics is way of getting information from a data. So information you can get in 2 ways. This information can be sorted in 2 ways. For example, simple exit poll. Now the last phase of UP elections are going to be maybe today or this week. This is complete. And once the last phase is complete, I don't know when is the last phase. Today's election or not? Or next week? No, not next week. 10th is the result, no? So maybe today may be an election. So after this election, you know, tomorrow all media will be debating on this exit poll. Now, what is this exit polls? In these two, what is exit poll? The first category or the last category?
Last category.
Isn't it? Exit poll, what do they do? They say this is the chance, like, for example, last time parliament election, the exit poll say that there are 300 to 340 seats may be won by NDA. They gave a chance of the range of values. And if they want to give 310 seats, then they will say 90% chance that they will get 310 seats. So exit poll is the best example of inferential statistics. So 2 branches of statistics. Descriptive. Descriptive is nothing but describing the current set of data. Current data set, describing the current data set, and then inferential. So what are the things coming in descriptive statistics? It's all about central tendency, measures, standard deviation, type of data, plots, etc., mean, median, mode, range, variance, standard deviation, etc. And in the inferential statistics, we are predicting behavior on whole data set. Exit poll. We take as in exit poll, we take, for example, UP around 20 crores people are voting. Now you cannot go to 20 crore people and ask their to whom they have voted. So they take a sample set. They take a sample. Based on sample, they predict the behavior of. They may take sample of maybe maximum some 1,000 voters. Based on the 1,000 voters, they are going to predict the total behavior. So predict the behavior of whole data set based on the central tendency data of the descriptive statistics. So with the help of descriptive statistics, you predict about the behavior. That's all about inferential. So when you predict, there is always a probability. You cannot predict 100%. So probability, chance is associated with that. You call it probability or you call it chance, whatever it may be. There is a chance and a probability associated with your answer. You cannot say 100% right. So that is inferential statistics. Now let's take a very simple example. I used to take this example in my Six Sigma program, green and black.
Sir, can you please
programs.
show
Yes,
the
yes,
types? Explain the types once more.
Pardon?
Explain the types once more, descriptive and inferential.
See, descriptive means it's all about describing a set of data. So what are the tools you use in describing a set of data? One is central tendency of the data and standard deviation of the data. Also, you plot the data in graphical summary. So what are the measures of descriptive statistics? You find mean, median, mode, range, variance, etc. And inferential statistics means the predicting part. Based on this, you predict of the computer. That's what I gave an example of exit poll. Where do you get the exit poll? That's what I said. 20 crore people are there almost on an average. I don't know exactly the figure. Almost 20 crore people voting in population is around 20 crore. So let's say around 18 crore people must have voted in UP election. So media person might have interviewed some 1,000 people. 1,000 people they interview, they survey, maybe 1,000 or 5,000, 10,000, I don't know exactly. But based on this, they are predicting about this 18 crore population of whom they have voted. And then they will come out with an exit poll, NDA will win this much seat, Akhilesh will win this much weight, Congress will win this much weight, SP, Samajwadi, likewise they can take. So it's all about predicting. Okay, don't worry, let me take an example, then it will be clear to you. So let me go to that example first. Then it will be clear to you. Just a minute. So I used to take an example, a very simple example in my combo program. So let's understand the descriptive statistics first. So let's take a very simple example. Now let's consider this as March. Now let's take some, we have around 20 people. So let's take height of the participants. Please tell me, 20 people, what is your height in centimeter? Now tell me, height is a continuous data or discrete data?
Continuous.
Continuous
Very
data.
good. So please, 20 people give their height in centimeter, please. Somebody can give me your height. Let me say mine is 134, okay? Somebody else? What happened?
165.
165 years then. क्या हुआ इस बैच को? ऐसे बैच नहीं होता है IICHE का बैच.
Sir, 170.
है 1?
170.
Okay, yes.
167, sir.
17.
173, sir.
173. Okay. Next.
181, sir.
Sir,
181.
181. Okay. Next.
167.
158.
158. Okay. Next. 167. Okay. Next. Next.
163.
160. Yes, please. Next. We have 60 people and I am not able to get even a 28. Just. Yes. If you are not sure, you can just give an average, right? क्या हुआ?
155, sir.
155. Okay, next.
So 178.
178. Okay, next.
172.
172. Okay, next.
166, sir.
166. Next. Yes. How many data we have? It's just not even. It's just only 12 data. 8 more. Yes. All 60 are there, or just they are showing number of people, or all have skipped the meeting? I feel only these 12 people are there in the meeting. All are there or not? Hello. Yes.
Yes, sir.
Yeah, tell me. Next. Just average data. If you're not sure of accurate data, just give me average. I need to eat more.
171.
171. Okay,
sir.
next.
So 173.
173. Okay, next.
160.
How much?
166.
166. Okay.
169.
Feeling no problem. At least somebody is there participating. Yes.
170, sir.
170. Okay, next.
152.
152. Next. Next.
164, sir.
164. Yes. Next.
169.
169. Next.
180.
181.
180.
180. Okay. Right. I think now we have to be. Just a minute, let me check how many. Yeah, thank God. I got 20 data. Okay. Now tell me, what is this? This is an observation, isn't it? What is data?
Yes.
Data is record of actual observation. Now, what is this observation that we have made? Height of participants in my March batch. Okay. So can I call it as data or not? Can I call it as data or not?
Yes, sir.
Yes, sir.
Now, let us understand descriptive statistics. Now, if you want to describe this data set, very simple, please learn it. Any data you want to describe, what is the best way to describe a data in one go? 3 information you can get in just one go. What are the 3 information you can get?
Mean, median, mode.
Mean is next. You need to do some calculation in mean. But see this, just if you get ascending order, just put a data in your ascending order. Smallest to
Maximum value and minimum values.
What are 3 things you got?
So you can get maximum value, you can get the minimum value, and you
What is
can
the
get the
lowest
mode.
value? What is the lowest value here? The lowest value?
152.
152.
152. And what is the highest value?
181.
180.
181. Very simple descriptive statistics, 181, the lowest value, the highest value. And once you get the lowest and highest value, what is the thing you can find out here? Have you heard about range? What is range?
Yes, sir. Highest
What is
minus
range?
lowest.
181 minus 152.
151 minus
152.
So highest minus lowest.
highest minus lowest, isn't it?
29.
E1, E2, highest minus lowest. What is the range? So three things, isn't it? So what do you say? When you say range, what is this range? Now, if I want to, now we can call this as X also. Let's call this as X. Now, X is always given in X-axis, isn't it? X-axis. So in the X-axis, what is this value, lowest value?
Yes, sir.
152.
152.
And what is the highest value?
181.
81.
And what is the difference between this distance?
29.
Between lowest and highest?
29.
29 centimeter. 152 centimeter. 181 centimeter. Now, did you get this very simple information, three information of your data set? Now, what is this? This is a sample set only, isn't it? Sample. Now, how many students we have? We have around 80 people. I don't know, before week I saw around 60. Let's consider we have 80 people. Now, 80 is your full. Now, we have taken sample of 20. So, how can you predict based on this 20? You can predict about 180, 80 people. Can you say what will be the lowest value of this 80 people? Chances are high that the minimum value will be 150 of this 80 also. For 80 people also, chances are there the lowest value is 152 and highest value is 181. The chances, not 100%. Okay. Now
Yes.
comes the next statistical thing. You know mean? What is mean? How do you find out mean? What is average?
Total number by number of observations.
Total number
Yes.
of
Now we can say mean.
Sum by
mean
total.
is
Sum by
summation
number
by
of
total number of observations.
average. Mean we can call it as is equal to, we can say average. So average and then give the range of values. And then let us give this range of value and you will get it. What is the average? Average, what is the average height of 20 people? Average height of 20 people. Mean height of 20 people.
Summation by total number of observations.
168.35. Yes, you know, you said right. Plus, first you calculate it, total, and then divided by 20, isn't it?
Yes.
So that will come as 168.35 only. You can give Excel formula. Now tell me, what will be the average of 80 people in this class?
Sir, for that you
What is
need
the chance?
for that you need the data of 80 people. You need the data
No,
of
you
80
don't
people.
have. That is what is inferential statistics. 80, you can get 80 people and do it. But what about 8,000? What about 8 lakhs? So what is the best way of for making that chance? Predicting. Now you have 20 people. So chances are there your average height of 80 people also will be almost same this. There is a chance. When you don't have anything, this is what exit poll people also do. They will go and under people, they will say how many people voted for BJP, how many people voted for Congress, how many people voted for SP. And based on that, they will predict, okay, 1,000 out of 1,000 people they surveyed. Suppose some 300 people say, 300 people say SP. And now around 600 people say BJP, and then around 40 people says Congress, and some around 20 people say some left or whatever it may be, any other party. So what do they do? They will say what they will say. Chances are there BJP will come. Maybe chances are there second there will be SP. Likewise, they say this only. This is what is SP. You have an exit poll. They will go for the sample and they will predict chances are there. Now, what is the chance? We cannot say 100%, but maybe 90% chance, maybe 95% chance. So I say 95% chance is that all this 180 people, 80 people have a height of 168.35. An average height may be 168.35. So it can be sometimes 168, it can be 169, but somewhere between this. Now, average is never going to be somewhere 150. No, average will be around this for 80 people also. Now, this is inferential and descriptive. Descriptive is 100% right because it is based on your existing data. But based on this, you want to predict. Right or not?
Yes, sir.
Now, what is the another thing you can find out? How do you find out standard deviation? You know how to find out standard deviation? Now, what is the lowest value?
152.
Highest value?
181.
And what is the mean? Central tendency?
168.35.
160?
8.35.
35. Now, what do? You will find each value, distance from each value. How much is the different distance from 150 to 168? So this is called
16.35.
X bar.
16.35.
X is 152 minus X bar 168.35. How much?
16.35.
Minus
16.35.
16.35. Okay.
Excuse me, sir. Isn't it x minus x bar whole square by n?
No, first you find for x minus x bar whole square, you need to find. I am asking only now the distance. I am not talking about complete formula. Let us come one by one. What is the first thing? You will find out the values 152. Here is 155. So you will find out the distance from 155 to 152. Next is 158. 158. So you will find out what is the distance from 158. And suppose you take 170. So here is somewhere 170. You will find out the distance from 170. 181. You will see how much distance it is from the mean. And then first of all, you will find out each value, how much distance is from the mean. So that is the first part. So let's do that. So the first part is x minus x bar. Let us call it as x minus x bar. X minus x bar. So it is equal to this minus 168.35. Now tell me, what is the average distance? What is actually standard deviation? Standard deviation is what? Tell me. The average distance of individual value from the mean.
From the mean value.
To find out the average distance, how will you find out average distance? How will you find out average?
Summating all the distances from the mean value.
Yes, so
and then
not
divided by
simple.
total.
How do you find the average? Just calculate the total value and then divided by the distance, divided by the total value. But what will happen? Suppose if you add all the value, some is in minus, some are in plus. So how will you find out that? For that, what you have to do? What is the next step then? you need to remove the minus, isn't it? So to remove the minus, we call it as square. Square, you have to square this. So is equal to this into this. So you have to square this. And then you will add this square, sum this square. So understood? First you will find out individual values sum, and then it is calculated. Now just tell me, can I call this sum of squares?
Yes.
Can I call? So what if I mention them as SS? Sum of squares. Can I?
Yes, sir.
So please remember this SS, word SS. This I will show you in ANOVA. Sum of square means just square of each individual value from the mean and squaring it, sum of square, and then adding square. Now, what is standard deviation? What is standard deviation actually? Standard deviation is nothing but average distance of individual value
from the mean value.
Average distance of individual value from the mean. So how do you get the average distance? Now to find out the average distance, what you will do?
X minus X bar by n.
The whole square by n.
That means X minus X bar whole square divided by what?
N. Number of observations, n.
N?
Yes.
Or anything
actually
else?
Should take an,
or anything else? Is it n or anything else?
Sir, it's n only.
Yes, n.
And actually, this should be under root if you found.
Is it n minus 1 or n?
CSTR में तो n ही पढ़ाया था. Sir, it should be n only.
Minus 1. Okay. So if I multiply now, what is this n minus 1? N minus 1 is called degree of freedom. Degree of freedom. Actually, what is happening? This is a mean. And you have 152, 150, 181. And you are actually taking from everything from the mean. So you are comparing with the mean. When you are comparing mean, you have lost 1 degree of freedom. So instead of 20, we take only 19 because everything is compared with this only, but this mean is not compared. Isn't it so? It is called, when you compare this, you lost 1 degree of freedom. And this is the formula for standard deviation of samples. When it is population standard deviation, it is X minus X bar. Sorry, it's X minus X bar divided by N. This is for population. For population, we take it as, but for our sample, every sample, we take it as N minus 1, and it is called degree of freedom. So here, if you divide it by degree of freedom, what is the degree of freedom?
19.
So this is sum of square. Sum of square divided by degree of freedom. What do you get? What do you call for that? What do you call it?
Standard deviation.
So sigma square. That's actually sigma square.
What is the name for that? Variance.
Variance. Yes, sir.
Remember?
Yes, sir.
Now, when sum of square is divided by difference average sum of square, so can you call it as mean square? Average is called as mean. And you are actually, this is a kind of average only, isn't it? Average. Average means sum of square divided by total number. Instead of total number, you have taken one less. So can you call mean square?
Yes, sir, we can.
Yes, please remember these two words. Why I am telling now, because I will recall it in another lecture. Sum of square, SS, MS. SS divided by degree of freedom is MS. Sum of square, mean square. Now mean square is nothing but variance. Now tell me, what is standard deviation?
Under
Standard
root of
deviation
variance.
is
Under root of
average
variance.
distance
Under root of variance.
from individual value from this. Now, what do you have to do? To find out the average distance, you have to square root the variance, square root of variance. So, standard deviation is equal to square root of sigma x minus x bar all square divided by n minus 1. This is standard deviation. So, we have standard deviation for next we can just do the standard deviation. So let's do the standard deviation. So standard deviation.
Sir, actually I had a doubt in this.
Standard deviation is equal to, you can have the formula in STD-DEV. Now there are two formulas, STD-DEVP and STD-DEVS. Which formula I have to take?
Sir, STD-DEV you should take. Deviation, right?
Yes. S part, S means sample. Sample.
Okay, yes.
So, and just give you this data and just enter, you get the standard deviation. Now what is the standard deviation? So there are two measures of a data set. One is, I can draw this like this because it's a continuous data. I have a mean. Mean is called central tendency. What is the central tendency of the data? Central tendency is 168.35. Now what is a spread? Now spread can be spread of the data and central tendency. These are the two things we do it in a descriptive statistics. Now what is this central tendency? Central tendency is mean. We can also have median, mode, etc. But mean is the best measure for central tendency. And for spread, you have two data, range and standard deviation. But you will have a doubt. Range is 29 and standard deviation 7.7. This is 29. Then where does the standard deviation represent? Standard deviation is also spread of the data, isn't it? Now this part, how standard deviation represents the width of the process, we will learn in the measure phase itself. Next week, we will learn it. Okay? But just understand what are the descriptive statistics measures. Now, this was of sample. Now, there is something called population. What is population? Suppose in UP election, same example, let's take. The survey team goes to and collected some 10,000 data. Suppose let's imagine 10,000 people have been surveyed. Now, what is this 10,000? It's called sample. But this sample have been drawn from where? From a population of 20 crore people or 18 crore people who have voted. So this is called population. Now, population does not mean human population. Any large set of data under study. Any large set, it's not only human population. It can be your tablet. In a pharmaceutical industry, number of tablets produced. In a year, maybe 2 crore tablets are produced, for example. Now, 2 crore is the population. But if you want to study this 2 crore population, you can take some 10,000 tablets and study and predict about 2 crore. So 10,000 becomes sample. So what is this data set? This is IICHE participant, this is sample, isn't it? Now I have a sample of November, August, September, October, January, February batch, so many samples. 1, 2, 3, 4, 5, 6, 7. Now let's say, now with this, I have a population. Now let's say, combinedly, I have copied this all into one. So let me copy this also into this. So can I call this as population? 141 people. So let's see what is the population of this. Mean of the population. Somewhere where what we got, what is our population mean average? 168.35.
Yes.
This is somewhere near to our own population, our own this one. Population of this, all the batches is somewhere on an average similar, very minor difference. And the lowest, almost similar. Standard deviation, almost similar. Now, how do you get this exact data? Now, this was my November batch. Mean of November batch. Mean of August batch. Mean of September batch. Mean of October batch. Mean of Jan batch. February batch. Now, let me put this mean of March data also. What was the mean of March data? Right? Now I call it as X bar November, X bar August, X bar September. We call mean as the X bar, isn't it? Now if I take the mean of the means, can I call it as X double bar?
Yes, sir, we can.
So shall we see what is the mean of this mean of the means? So let me take it as X double bar, X double bar, XDB. Let me call it as X double bar. So how will you find out? Just go to this and is equal to average. And then I give this. What is average?
AVG from this to this. Average of AVG I22, I32, I10.
Isn't it? So can I call it as mean of the means?
Sir, that would be a weighted average.
Mean of sample means?
Yes, sir.
Now tell me, this mean of sample means, is it equal to the population mean?
Yes, sir. It seems
all the data.
It
So
seems
mean of the
almost
sample
equal,
mean is equal to population mean or not?
Yes, sir.
So what is the best estimator? Now here I have what? This is my sample data. Based on this, I can estimate, I can infer. So what is the best way of inferring for population mean? The population mean is equal to mean of the sample means. So take more and more samples and find out the mean average of that sample, and that sample is equal to population mean. Now this is one theorem called central limit theorem. CLT. Let me tell you, all these things are not in detail in yellow belt, but I am just giving you in detail. So that what is one purpose is, if you want to go for a black belt, so that a green belt or black belt, you don't have to spend much time. Most of the things have been covered. Only just a 3-4 days. You can. Anybody wants to go for a green belt, you can go for it. I'll give an offer if you are interested. I just wanted to know how many people are interested. Then I'll tell that. So this is called central limit theorem. So central limit theorem, one of this is called the mean of the sample mean is equal to population mean. Understood? Is it clear? Any doubt here? So this, what we have done is a type of descriptive statistics. So I'll just show you this in a mini tab. So all these things, whatever descriptive statistics we have done, let me show you in a Minitab software. Minitab is equal to Six Sigma. If you want, without knowing Minitab software, you're not complete. Your Six Sigma learning is not complete. Not in yellow belt I'm talking. Just a black belt and Minitab, if you're not learning, then you're not learned Six Sigma. So Minitab is a statistical software. You have so many software. SPSS is there, Power BI is there, but SPSS is most famous with the PhD people. Any people wants to go for a PhD research, most of the people use SPSS because that is good for survey. Anybody wants to learn Six Sigma, Minitab is the best software. Anybody wants some other kind of analysis, big data analysis, and Power BI is the best software. So many softwares are there. Minitab is the best software for Six Sigma. Now, same descriptive statistics, let me show you. Now, let's take it as basic statistics, graphical summary, and let me take height of the participants, select, okay. This is an histogram, isn't it? Now, everything what we have done is here. Now, let me show once again, gross statistics and graphical summary. So we are in the graphical summary, we are putting the height of the participants. Now, have you seen a confidence level here? What is this 95%? 95%, it is nothing but the percentage. Means you are going to infer something. So what is the chance of your inference, probability of your inference? Generally, it is 95%. 95% means when you are inferring something, you are inferring something with a 95% confidence. You can infer with 90% confidence also, you can infer with 99% confidence also. So inferential statistics is generally done with a 95% confidence. That's why I said, whenever you are inferring, you have to say, associate what is the percentage, confidence. You cannot be 100% right. Never. You can never be. You can only be either 90% right, 95% right, 99% right, like this. Generally, it is used 95%. And see this, all those measures what we have done is in one go, we got in Minitab, mean, standard deviation, variance, minimum value, maximum value. Then there is first quartile, third quartile, we'll learn it later. Then there is a p-value. This is going to be learned in green belt and black belt. What is p-value? How to identify with, how to analyze with the p-value, etc. Now this looks like a normal curve or not? This is a curve called normal curve. Normal curve. This is also called as bell curve. Very, very important curve. Bell curve. Okay. And let me show you some more data. For example, just a minute. Suppose, what if I have 10 lakh, height of 10 lakh students? What if, how does it look like? Suppose it is a height of 80 student. What if I get 1,000 students? How will it look like? Let's see this. height of students, 80 students. You got it? Height of 80 student, it looks like this. Now I have height of 1000 students. Let's see, height of 1000 students. How does it look like? If you see, the curve is more like a bell. So let me go for a height of 10,000 students. Height of 10,000 students. When you get the more number of data, the curve is getting more and more bell curve, bell shape. And let's see my height of students of 1 lakh students. See this. Suppose I have suppose if I have 10 lakh students data, let me see how it looks like. How does it look like? A proper bell curve. It's called a normal distribution. It's very, very important distribution in Six Sigma problem solving. There are so many properties of normal distribution. We'll be learning the properties of normal distribution later next Sunday. This is enough for today. Yes, any discussion you need, any clarification you need. Let me know, please. You all are there or not?
Yes, sir.
Yes, sir. No, sir, not now. Not until now.
Not now means you are there or you don't have any doubt?
Sir, I am there, sir. I don't have any doubt until now.
Okay. Good. Okay.
Sir, actually, I had a doubt.
Yeah.
In calculation of standard deviation, instead of using squares, can we use absolute values also?
See, actually, these formulas have been. I also had this. Doubt. Why not using absolute value and just squaring?
Because
This is a method defined by statistician over hundreds of years, trial and error method. So they are derived to this standard. Now we have softwares, but imagine 50, 60 or 100 years before, this person like Walter Shewhart, who developed this SQC techniques and all, Deming, all these people used to do this by calculating it manually. Imagine. And these formulas have been developed over 100, 200 years. So there may be some reason. So it's a standard formula. So instead of taking absolute value, they have squared it to remove the negative value and then.
But actually, in our curriculum, we have a subject relating this numerical techniques. So in that, in error calculation, we were considering sum of square errors. But that has a specific, I can say, specific means. But here, I cannot understand why they are using squares. Instead of that, we can use absolute values also now.
So that is what I'm telling. This is part of statistics.
So that is a predefined way. That's why we are using that, right?
Yes. This has been used even statistical formula is based on this only. Standard deviation is found in this. Now that's the difference. See, if you see this, I said no, the range and standard deviation. Now, how standard deviation is related to this? Because this is the width, this is the range, spread. But if you take the lowest and highest, this is 29. But standard deviation is 7.50 only. Now, how standard deviation is related to this spread? We will learn it next Sunday. Because standard deviation is the best measure for this spread, not range. Range is used for small, just when you have only 4 or 5 set of data, there you can use the range is better measure than standard deviation. But when you have sample size more than 10, standard deviation is a better measure. So standard deviation and process width, how is this related? We'll learn later. So this is how statistics based on statistical theory, this is the formula for variance and all. Okay. So I also had this why not absolute value, but maybe some reason I didn't go much into that. I didn't research into that. We don't have time to do all these things. But of course you can do. You people can question it. You people can search it. Why not, etc. Okay. Anybody else?